And we're going to finish it here. All right, so it says, the first part of it says to find the acceleration of the ride in each interval. And if we have a velocity versus time graph, right? Now, what is the y-axis? Velocity. What's the x-axis? So the slope would be what over what? Delta v over delta t, which we know is acceleration. So slope on a velocity versus time graph is the acceleration, okay? So the slope here, the change in y would be 30, right? The change in x, or time, would be 3, so that gives you 10 meters per second squared. Follow? Here, there's no change in y, so no change in v, that's 0. And then here we go from 30 to 0 in 1, 2, 3, 4 seconds. So minus 30 over 4 is 7.5. Do you need me to do these out for you? Or do you get how I'm getting those? Carolyn, you get it? Tyler? Get the slope, get the acceleration. Now it says compute the displacement of the ride in each interval A, B, C. What would you do for that? Yeah. The area under the curve, right? Because average velocity over this interval would be this plus this divided by 2 times the time, right? So it ends up being the area under the curve, or 1/2 base times height. So your displacement will equal 1/2 base times height, or 1/2 3 seconds times a height of 30 meters per second, or 45 meters. That's for this one. For the red one, the shape is a rectangle. So delta S is base times height. Delta S is 1, 2, 3, 4, 5 seconds times 30 meters per second, or 150 meters. That's that area. And then this area over here, one-half base times height, 1/2 of 1, 2, 3, 4 seconds times 30 meters per second. It's still positive. It's still above. It would be negative displacement if this curve went below the axis, because that would mean now that you have a velocity that's negative, which means that you're moving back towards where you started. I see. So, but we don't have that here. 1/2 of 4 is 2. Wait a minute. Yeah, no, that's right. 260 meters. Okay? What is the speed of the ride at t equals 5 seconds? 30 meters per second. How about 9 seconds? About 21 meters per second. You could just estimate. That would be fine. What is the total distance the ride traveled? Just add up all your disti's. You like that joke? No? Add up all your disti's. 210, 255 meters. Alrighty. What was the average speed for the ride's entire motion? Well, no. No, you want to do delta S over delta T. Because what's the average speed for the entire ride could be different if, like, say, if I ran an average speed of 5 meters per second down the hall, and then I ran an average speed of 10 meters per second all the way across around the park, the average speed for the entire motion is not 5 plus 10 divided by 2, right? Because the distance, how long that distance is matters, and how much time matters. So to get the average speed for the entire motion here, you just do delta S over delta T. You take your total distance traveled and your total time, which was 12 seconds, and you calculate it that way. .25. There were parents in here this morning, so if you're wondering who I'm talking to, if one of you watch the videos later, that's who it is. And the guy that I started swearing at started to attack me first. No, that's not true. That would be funny, though. Actually, well, maybe it would. I don't know. I did, yeah. Yeah. Now, imagine if you're the kid and you have to go back to school. How embarrassing is that? Dad embarrassed me again. All right, so the page prior to that has a couple problems. I already did this one, but let's look at this weather balloon one. I'll get back to that. Extra credit on the review packet, right? You don't get any credit for it, but it's because I pulled it off of other things. A stationary weather balloon up in the air drops a sandbag. The page prior. So it falls out and it hits the ground with a velocity of minus 80 meters per second. And it started with 0 meters per second. How high up is it? Fill in the chart. So we start at 0. We end at minus 80. We also know A, since it's in free fall. Yes. Well, let's see if it is. So average speed here would be what? Minus 40. delta V, or average velocity really. Delta V would be this minus that, or minus 80. A is delta V over delta T, which is minus 80 over 10. Oh, no, no, no. I'm sorry. Yeah, so delta T is delta V over A, or minus 80 meters per second over minus 10 meters per second squared, or 8 seconds. So Austin, how am I going to get delta S? Minus 40 meters per second times delta T of 8 seconds. Oh, wait, what were we trying to do? Oh, yeah. 40 times 8 minus 320 meters. So, yeah. So, how high is the balloon? It's 320 meters high. It comes out negative in our chart because that's what it fell. Yes. 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 Number 2 was yes. Next question. Okay, so little Tommy goes down 125 meter long sled hill. 30 degrees. How long does the ride last? For this, we'll start at 0 again. We're going down the hill, so we'll say minus 125 meters. What else do we know? I need to know something else. A equals G sine theta. A in the plane is G sine theta. Frictionless, we're assuming. Minus 10 meters per second squared times the sine of 30 is minus 5 meters per second squared. Where's your exam for this class? In here. What time do you have to be here? On what day? On Tuesday. It's 8:45. Jeez. Okay, so now we have all that, and we could solve as we have done many times before. We could use our Wolf squared equation. Two times 5 times 125. 1250. Right? Square root it. And VF would be negative. It's going downhill. It could be both positive or negative. Whoops. 35.4 meters per second. 35.4, I think. Negative, yeah. So the average velocity is 17.7 minus 17.7. Delta V would be that minus that. from the previous problem. We know delta T is delta V over A for about 7 seconds, right? .1 seconds. Okay? Is that clear? No response? What's next? Oh, we're right at the parabola ones. All right, you want to go right to this one? Sure. All right. So a basketball is shot with a speed of 12 meters per second at an angle of 65 degrees from the initial height of 2.6 meters above the ground. The net is 3.048 meters above the ground. Assuming the shot's good, how far from the basket was the player standing? Draw a picture and fill in the chart. Okay, pitcher, person. So, actually, oh, what happened? Let's make the person a little taller. So when the ball is shot, it says that the initial height above the ground is 2.6 meters. The reason that it's so important to put the figure on these is because you have to figure out heights and stuff. And if you have like this information, like 2.6 meters, and then you know the ball goes up, and goes in a basket, right there, and the net, we know, is 3.048 above the ground. Okay. Assuming the shot's good, how far from the basket is the player standing? So we want this information. Okay. So it's at an angle of 65 degrees at 12 meters per second. So we'll break that up and we'll take that 12 meters per second at 65 degrees and we'll find a Vx and a Vy, won't we? What's my equation for Vx? Okay, V cosine theta, so 12 cosine of 65 degrees, or 5.07 meters per second. And Vy, similarly, would be 12 meters per second sine of 65 degrees, or 10.9 meters per second. Oh, man. Okay, so how does the Vx work? It stays the same throughout. Good. Right, there's no friction, nothing, no forces in the x direction. So all that we know. The y up, the initial y up, we have that. It's 10.9. We also know that this is minus 10. We don't know the initial, like, we'll have to put other stuff in. We know that this goes to 0. We go up to 0, right? The speed of the basketball, you shoot it at the top of the apex, the speed is 0 in the y direction. And then as it starts coming back down, it's 0 coming back down. Those are the same point in time. So we don't know this. We need to get it. How high up does it go? We don't know yet. Okay, so the rest of the stuff we'll fill in. So to get V bar here, I divide that by 2 and get 5.4 meters per second. VF, or delta V, is VF minus VI, which is minus 10.9. Delta T would be delta V divided by A, or 1.09 seconds. Everybody follow how I got that? Okay, so delta S is V bar delta T, or 5.4 meters per second times 1.09 seconds, or 5.9 meters. So we're going to go 5.9 meters up total. Okay, so that's this. That's how high it goes up in the y direction from where it left, right? Quite the shot. That's 5.9 meters, isn't it? Because that's from where the ball left the hand to how high up it goes from there. So we need to find, so yeah, it's quite the shot, right? Yes. Yeah, so we have to find how far down. It's not drawn to scale, obviously. But we want to find how far down it's going to go so we can plug this into here, right? We need to find this much that it came down. So we know we can get the total distance by adding those together, 5.9 plus 2.6. That's 8.5 meters high. And then subtract 3.048. We get 5.452 meters is going to fall. Or let's just say 5.5 meters down. Does that make sense? 5.5 meters. It's more like the person kicked the ball up. Way up above the gym. Must have been outside. And then it came down. So this is going to be a minus 5.5 meters that it's going to fall. And now we could solve for VF. So VF squared equals VI squared plus 2A delta S. And VF squared equals 0 plus 2 times minus 10 times minus 5.5 meters, or 110. Square root of that is 10.5 meters per second. And it's negative, it's coming down. So that goes in here. So V bar would be that divided by 2, or 5.2 minus 5.2, that's minus 10.5. That divided by that is 1.05 seconds. So the ball was going up 1.09 seconds and then falling down 1.05 seconds. So to get this delta S that it travels in the x, we have to add the total time that it's going up and the total time that it's coming down, because that's the time that it's moving forward this way at this speed of 5.07 meters per second. So that would give us 2.14, right? 2.14 seconds. And then this delta S is V bar times delta T, or 5.07 meters per second times 2.14 seconds, or 10.8 meters. That's how far from the basket the player is. Did you get that? Here? Oh, that's from, it was shot 2.6 meters above the ground. Okay, that's one point of it. How far up does the ball go? Well, the ball goes up from this 5.9 meters. So the total amount that it goes above the ground is 2.6 plus 5.9. Then you have to subtract off the height of the basket, because that's where it's going to go. How far does it fall down? It falls down this amount right here. That would be this total minus this is 5.5. Okay, well, that'll wrap it up.